Hi, I'm Mariko, as introduced. My Twitter handle is this, and that's my icon, if you know me from Twitter. I write a JavaScript at a company called Scripto, and I do not do this as a job. I'm a web application engineer at a company called Scripto. I also co-organize a meetup in Brooklyn, New York called BrooklynJS. And it's interesting, it's just happening as a Thursday night right now in Brooklyn, New York. So I've been getting a lot of tweets. It's our 2-year anniversary. So it's really honored to be here speaking about this at a JSConf family. I also make textile with JavaScript, and that's what I'm talking today. What do you mean by making textile with JavaScript? Well, that means my weekend desk look like this. Computer in the middle, yarns, and my knitting machine. So the title of the talk is Electroknit, Textile to Textile, and I'm going to explain how a digital photo image gets into textile pattern to knit. So as I mentioned, I design and I knit in JavaScript. So I'm going to explain a little bit about knitting with JavaScript part first. So here's a little video of me operating a knitting machine. So I wrote a code, node-based code, to talk to this machine from 80s. This machine was developed in 80s. Well, it's been made since way, way before time. And in 80s, they made this knitting machine that is a Elektroknit, which is computerized knitting machine. And this year, I took on the project to figure out how to talk to this machine from my computer, because this was made in 80s, way before Apple computer. So it's designed to talk to a special module that gets a floppy disk as a data, and then store the data. It actually plugs into your TV monitor, and then you have a controller, joystick, to program the patterns into it. So I wanted to do that from my computer. A lot of people have hacked on this, so I researched a lot of code written by other language, and I thought, why not JavaScript? So I started doing this. And so as I mentioned, it has a computer. And I presented at a JSConf US in May, and it's very nice to get to talk what came after that at a JSConf.Asia in Singapore. So this is run by computer, but a model before this knitting machine was operated by punch card, much like how all the computers were operated by punch card. So right after I figured out how to operate this machine, I got really interested in punch card mechanism, and I kind of prototyped my own punch card computer and programmed it with Johnny 5, which is a JavaScript robotics framework. So what it does is it takes a punch card. It's a huge punch card that I designed. It takes it. If there's a hole, it won't push the pin. If there isn't a hole, then it pushes the pin, and that gets the input of it. And this is kind of a little mock-up of a web application that is designing the textile by punch card input. So this whole thing about doing JavaScript and knitting came when I actually was studying JavaScript and to be able to code. I was a knitter way before I became an engineer. And I noticed that when I was learning JavaScript, I noticed that the JavaScript is really like knitting, or coding is like knitting. Knitting, atomic unit for knitting is 2 stitches, much like computer is 1s and 0s. It's knit stitch and purl stitch. And it creates a very different face of the fabric. And the combination of those creates a cuff of your sweater or neckline, or an elaborate pattern in there. The code or pattern for knitting, the instruction to knit certain sweaters or scarf, comes in the form of code. So that means you can knit in JavaScript. So first line of this instruction is CO5, meaning cast on 5, start of width of 5, which is like creating a new array of length 5. And next one, K5, meaning put 5 knit stitches into that array. M1 is make 1. So now you're expanding the size of the array. which is like operating a scarf.splice method. And there's much more clear loop indication in knitting code or pattern. Knit until 2 stitches remaining, meaning much like while loop, until there's a count of 2, just append knit stitches into the array. So now if you can switch to this machine, basically this machine knits way faster than your hand can knit. It's doing the same thing. It's appending the knit stitches inside it, but it is going to do it way faster than you can do. So is the feed switched to the camera?
Yeah.
If not, I can show the video.
Can we focus the camera to the knitting machine instead of the slides?
Should we video? Maybe technical difficulties. We'll come back to it later.
No. You're here.
Oh, there you go. All right. So as you can see, if you can focus on this area, this is a width of 60 array to me. And when you pull this handle, it knits a 1 row of fabric. And to me, this is much like creating an array and appending into the matrix. So you can see this is creating 1 row by row, knitting a little by little. But if you hand knit, this is way faster than you do at hand. So can you switch to the slide? So now I figure out how to talk to this machine, put the data in, and then knit. And I started knitting. And I thought, instead of just taking an image, it would be cool if I can JavaScript to make actual image too. So I started doing this nerdy knit project. First, I did creating a D3 visualization and exporting it as an image and put it into the machine so that the pattern for this scarf is actually made by JavaScript. The other project that I did was creating a domain-specific language for knitting. So again, this is written in JavaScript, web application. Little cursor is running, made by img-tag. I can type and change the pattern interactively, and then you download and then load it in. The other one I did was one day, somebody from Travis CI tweeted that they had an API outage, and they had this beautiful, or maybe sad, graph of their access dropping down. And somebody, not knowing anything about what I do, tweeted that it would be great if I can make a scarf out of it. My friend, who knew I do JavaScript knitting, tweeted at me saying, like, maybe you can make this. And I was like, I totally can. So I made it and then sent it to Germany office of Travis CI. So those are the kind of things. JavaScript through and through, creating an image, put it into the machine is what I do. After I figured out how to use this machine and how to hack on it, I started making a lot of knitwear. And then there was a lot of friction, and friction was using Photoshop. Just the color image is not automatically loadable to a machine. I have to do a lot of image processing, and I was using Photoshop. But I was like, hey, why not do it in JavaScript, right? Image processing, doing JavaScript. If you think about image processing, I immediately think, oh, maybe I should learn language C or using a framework like OpenCV. But I'm a kind of developer who started making buttons move by JavaScript. I didn't go to computer science college. I just started making websites and then learned to code. So JavaScript is pretty much my choice of language and what I do. So let's do this in JavaScript, right? So the process of making a color image into this machine is 3 steps. First, you need to get a raster graphics, which I will explain what it is in a minute. And then do image processing, whether you want to change the color or invert the color, do whatever you want. And then last step is making it into one bitmap image, which I will explain. But what it means is that just compressing the data so that it is representable by just 2 colors, or even 1 color, color or no color, because my machine only takes 2 colors of yarn. It is not a web-safe color variety of yarns, right? So let's start. The raster graphics. What does that mean that I need a raster graphic? Well, the raster graphic is best explained by a collection of pixels. So this is my movie that I took from using a color picker. You can see the magnified version of the picture. Each pixel has a color data. So you can think that the knitting is really like a pixel art. The stitch cannot be bent from point A to B by making straight line. I have to draw a line saying like left, left, up, left, left, up. So you can think of the raster image as like a collection of pixels information. The one that's the opposite of raster is a vector, like what I explained. It's like a SVG. You define, I want line from point A to point B. But that's not how knitting works, so you need a raster. So I need to get a raster image, right? Collection of image. But like, what do you mean by like getting a data out of image? Like, I only know like using img-tag. And I've never like rendered a picture pixel by pixel. How do I do that? Well, actually, you can do it as a JavaScript engineer using Canvas of HTML5. You create a canvas and assume that you loaded some kind of image into this canvas. And you use a getImageData method to get an array of numbers. And this is a flat array of numbers, which start from the top pixel corner of 1x, 1y, RGB, red, green, and blue value, and then the alpha means opacity. So if you do the CSS color in RGBA, you are much familiar with this format. It's basically a flat array of all the pixel information of that image. So now I have a data. That means I can emulate in Canvas how computer displays an image. And I padded the array so that it's a lot easier to read. So let's create an output canvas object, another one, to have fun with it, and create a function of draw. Draw function gets XY coordinates of the pixel, and then 3 colors to represent that pixel. And every time this function is called, you append a colored rectangle into the canvas object. So first one is blue, which is red is 0, green is 43, blue is 125, and opacity of no opacity really. And then you get lighter blue, and then next one is yellow and yellow. So this is how computer renders image based on the pixel data that you can get from the canvas. So that means you can manipulate or like intercept this draw function and then have fun with it. So let's invert the color. Inverting the color is flipping the value. So basically, you get a red, green, and blue value, subtract it from 255, and then use that number instead. So you do that and then get the invert image. Draw, maybe you can just increase the value of just the blue color. In that case, you add, in this demo, I added the 60, and then blue gets blue R, and yellow gets less yellow. You can also grayscale an image. And I use very simple algorithm to do grayscaling. Grayscaling, there's a many ways to do it. The way I'm doing it is not the most accurate to the human eye, but my grayscale image will eventually goes into this 2-colored fabric. So I don't really need a sophisticated algorithm to do it. So the way to do it, or the way I do it, is you get a color, RGB value. You find the largest value in those RGB. Repeat that for 3 times, and then you get grayscale the color. So now you manipulated the color. Let's do something more fun, like let's blur a photo or sharpen the photo, or let's find the edge. Because sometimes I take a photo of something, and I only want to represent the outline of the thing. And I load it into Photoshop and draw the line from that object to get the thing. But if I can do it in automatically, that would be cool. In order to do that, all 3 of them use the same method called kernel convolution. But I like to call it as a pixel social graph. And it really is a friendship between pixels. So you get an image. Again, I'm using a grayscale because grayscale image, again, only has a 1 value per pixel, so it's easier for demo. If you want to do it in color, you just repeat it 3 times across RGB. Again, each pixel has 1 color or 1 number. You introduce this idea of convolution and kernel, but I'd like to think it as a pixel social graph. So the center is you. You are the kernel. You give number to yourself, how valuable you are. The surrounding pixels are your friends. And you also give a number to friends, how valuable they are. So you get to choose, like, I like this left-hand guy, 2, and then right-hand side, 3. You can choose your friendship, right? It's basically how much of your friend or which corner of your friend you let affects you more. You overlay that invisible window there. So let's look at this kernel 134, and we're going to figure out what to change, right? Start from the corner. You take actual value of the pixel, and then multiply by the friendship level that you define. So in this case, 1, so it stays as 159. Next one is 2, so doubled in 272. Next one is 1, stays as 63. And then you do that for whole 9 pixels, and then get the total of 2061. You divide it by the total amount in this convolution or your social graph. Divide it by that, and then you get 28. So next time you render, draw image, you use 128 instead of 134. You do that for every single pixel. This one, 90 gets 80, 42 gets 54. You do that every single one, and then you can get an image process data. So let's look at some of the effects. So the social graph that we used in the example creates a blur. Maybe it's a little harder to see, but you can see that the photo is blurring. Blur function is not only to make image fuzzy, it's a way to get rid of noise. So if you have a noisy photo, you can blur it and then sharpen it again and to get make a smooth photo. Next one, you decide your friends are a little more negative than you are, right? Your top, down, left, right friends are -1, and then the diagonal corners are 0. That gets you a sharp edge. So you can see that before and after. The next one is edge detection. So this time, you're really valuable, but your friends are not, right? And instead of dividing by total sum of the number, this time you divide it by number of pixel or the size of the matrix. So this time 9. Divided by 9, you get a line from the picture. Maybe a little hard to see it, but you can see it. So doing this was really slow, because remember, just drawing the picture is number of pixels, but then you added the computation 9 more times to calculate what this value would be. So I was like, can I make this parallel? Yes, you can with web workers. What do you mean parallel with web workers, right? JavaScript is single-threaded. Well, web worker is a magic thing that lives in browser that I did not know until now. It's a piece of JavaScript that runs on the background, separated from your browser's JS thread. So you can hands-on the data into Worker.js, and while Worker.js is doing heavy computation, it will not block your UI being animated. So Worker, from now on, the few slides are about web workers, so if you know, you can just skip it. So you make a new worker by new worker, and then get a path to the Worker.js. The host's JavaScript and the worker JavaScript talks in the method called post message. And each of them has an event called a on message, and listening to the post message fired. Post message have one argument. So if you want to pass many data, like in this case, I am passing ID and data, you needed to put it into the JavaScript project so that the argument is 1. Worker.js can be multiplied so that you are parallel processing. In that case, host.js starts as 1, but then you fire up as many workers you want. So in my case, I divided up my image into multiple workers, get just this area for worker 1 of the data, and pass it into web workers and doing it. It made it faster. However, this is not a magic function for everything. The trick is, you are passing and copying a data every time you fire up the worker. So this data part, you are copying the data. So if you're doing a simple thing, and copying the data takes more than your computation of simple computation, it gets actually slower than just doing it in a single process. So this is kind of give and take, but if you have really heavy computation work, web workers makes it faster. So we covered what the raster graphic is, and then how to do the image processing on the data from raster graphic. Let's talk about how to make it into 2 colors so that I can represent it into yarn. You can start from color image, but in that case, you needed to make it to grayscale first. The grayscale image, you may think it is black and white photography, so it's already ready for 2 colors. But in fact, grayscale image is a white pixel, black pixel, and many shades of gray in between. So I absolutely need 2 colors like this. One way to do it is split it in half or put the threshold somewhere. And anything over than that number gets white, anything less than that number gets black, and you get image like this. This works very well if you're dealing with logo data or graphics data, not a photography, sadly. You can see the definition of the lion gets washed away. In order to preserve that, like what newspaper does, you need to do things called dithering. Dithering start again with image data that you get from grayscale image. Each pixel gets 1 number. You apply a noise matrix or dithering matrix and overlay it. You compare the under pixel and then the overlaid pixel value. If it's lower, the image input is lower than the dithering matrix, it gets white. If it's over, then it gets black. And you can represent that in 1 and 0. 1-bit image. So the output of that would look like this. So you may think this is gray from far back, but this is actually represented in just white and black pixels. And that way, I can use 2 yarns to represent this image. So once I figured that out, I was like, OK, I can automate my process to create an image for this knitting machine. I can save that data in some kind of JSON or something, because up until now, it is just an array of information, right? I'm just using that array of information to render on my screen, not as an image. Can I download that as an image file? Because it's a lot easier and portable to keep track of. It should be able to do that, right? Because we download image from web all the time. So my thinking was that, OK, I know the type of, well, what do you call it? The type of the array that the Canvas object takes. So let's create that. I have 1010, but then convert it into 255, 255, 255, opacity for 255 pixel, and then 000 255 pixel. Create a new Canvas object, put that data into Canvas, and then once it's in Canvas, you can use toData URL to get a base 64 representation of that image. And then you can just put it into URL and then download the image. However, this did not work. Specifically, this part did not work. And this part was the problem. It was not just updating the data. And I was looking at this inspector, and why is it not doing this? Because it's array. Because I assumed that it's array because it came back in square bracket. Looking closely into it, this was something called Unit 8 clumped array. And I was like, what is that? What is that? I mean, I have never seen this thing in my inspector before. I mean, granted, I wasn't a game developer. I wasn't dealing with a lot of Canvas at all. But like, what? This thing is called typed array. And first of all, typed. It's JavaScript. It's not typed. What do you mean, typed? Well, let's talk about JavaScript array first. So regular array is a magical thing that takes any type of information, put it into one collection, right? So you can create an array, you specify index and put the 1, or push 2, or you can push the object or string. And then the output of it looks like this. The JavaScript array, to me, is like a baking tray that you put in, and then it takes like anything, any shape, any size. If you want to bake a chicken right next to a cinnamon roll, you can also do that too. So it's like very, very useful thing. But it needs to expect a lot of possibility when it's doing the computation. The typed array, to me, is a muffin tin. It is very specifically designed and very specific size to hold specific thing, right? It can be muffin tin, it can be donut mold, it can be, I don't know, but you know, the factory makes it specific product for specific shape and size. So that's typed array. So typed array, the size and shape is defined in this part. So unit 8, meaning 8-bit of unsigned integer. So that means you put, anything you put has to be 8-bit unsigned integer. If you put more than 8-bit, so 8-bit is 0 to 255. If you put more than 255, then it will just hold an overflow from that. If you put anything that is not integer, like string, it will just not put it in there for you. It just stays as 0. And if you put a number that's within, then it will just keep that number. So here is a list of typed array. And what I specifically needed was unit 8 clumped array. 8-bit unsigned integer, parentheses, clumped. No explanation. What does that mean? So I did a little bit of search, and clumped means is that any overrides from the muffin, just cut it off. It has to be exactly the same size within this defined range. So unit 8, again, so 0 to 255. Anything more than that, it gets 255. Anything less than that gets 0. So if you assign 280, then it gets 255. And if you assign minus 30, it gets 0. This does good thing when computer is only expecting one thing and doesn't have to think about any other possibility. The computation gets faster. And that's part of the web browser that enabling a lot of games and things that we feel like it's native. So I modified my code. One thing is that the typed array doesn't have same method as the regular array, so you can't do the push. So I specifically defined the index and then assigned the value from my base array, and I was able to download it. So at the end of this exercise or journey that I was doing, I was like, surprisingly, I just wanted to knit, but then I learned a lot about web by just knitting. And I really recommend doing that, all the things. I was a web developer. I wasn't a hardware hacker. I just wanted to do a fun project with JavaScript. And I learned how to talk to machines. I learned what the clumped array is. I learned what web worker is. And like from now on, whenever I see an opportunity in my web application coding, I totally going to use the web worker and clumped arrays, right? So my suggestion is that like if you think anything that you like and possibly compute it by computer, you should try it. And I promise you that you will learn something new that you can use in daily life. So here's a few resources of my project. So right now, loading the data into machine and creating an image is two separate projects. But I'm creating one application so that on the UI, just you click on it and then load it into machine. So that code will be up on the repo. I specifically like to thank Zach Lieberman and School for Political Computation who let me sit in their Pixel class. That's where I learned a lot of image processing. So thank you. That's my Twitter handle. If you have any question, please tweet at me or DM me. And I have a feedback form on web, bit.ly/pixel2knit. If you like the talk or didn't like the talk, I'd love your feedback. Thank you so much.
Thank you, Mariko.